Chapter 4 Applications of Differentiations. Okay guys, so this is still 4.2 extremum problems, which is cost framework C, optimization problem. First, let's take a look at the quick view definition. The largest or smallest value of a function subject to some kind of constraint. The constraint will be some conditions that can usually be described by some equation. So this is several formula for area and volume for several solids that we will discuss later. How to solve optimization problems? First, identify the variable to maximize or minimize, let's say variable y. Second, express y into a single variable function, let's say y equals to fx. Third, solve f prime x equals to 0. Fourth, verify the type of solutions of f prime x equals to 0 using the first or second derivative test. And lastly, get the optimal value y equals to fx if it is required. Let's discuss example 1. An open top box is to be made by cutting small congruent squares from the corners of a 12 cm by 12 cm sheet of tin and bending up the sides. How large should the squares cut from the corners be to make the volume of box maximum? So here is the drawing. First, let's come out with the volume since the questions asks us to find a maximum volume. Okay, so we will have V equals to X multiplied with 12 minus 2X and 12 minus 2X. Okay, so 12 minus 2X because we have the length which is 12 minus with the two edges with the length X. And X here will be the height. Okay, so we expand. We will have 144 x minus 48x squared plus 4x cubed. Okay, so from here we find dv dx, okay, which 144 minus 96x plus 12x squared. Okay, so from here we equal this dv dx, okay, 12x squared minus 96x plus 144 equals to 0. So after we simplify, okay, and then factorize, we will have x minus 6 times x minus 2 equals to 0. So we will have x equals to 6, x equals to 2. Okay, we have two options here. It's either x equals to 6 or x equals to 2. So how to test which x value that maximize the volume? We need to apply test. Either first derivative test or second derivative test. So I want to try with second derivative test. Okay, next we must find second derivative. So d2v dx2, we will have negative 96 plus 24x. Okay, then we substitute x equals to 6 first into second derivative. Okay, we substitute, we will have negative 96 plus 24 times 6, which imply 48. Where 48 is greater than 0, that means it's minimum. Okay, then we substitute x equals to 2 into second derivative. So we will have negative 96 plus 24 times 2, okay, which imply negative 48, which less than 0. So that means it's maximum. Okay, so x equals to 2, we make a conclusion. X equals to 2, okay, maximize the volume. Okay, but the questions asks us how large should the square cut from the corner? Okay, how large the square? So the answer will be the area, which is x squared. So 2 squared. So the answer here is 4 centimeter square. Okay, let's go with example 2. A manufacturer needs to make a cylindrical can that will hold 1.5 liters of liquid. determine the dimensions of the can that will minimize the amount of material used in its constructions. Okay, so we list all the informations given, which first very clear here, it said that 1.5 liters, that means this is the volume. Okay, the volume is 1.5. Okay, so refer to the informations for area and volumes of solids that we provide, okay, at the first slide. Right, so find out what is the formula volume for cylindrical. It is a pi r square h, okay, equals to 1.5. That means h equals to 1.5 over pi r square. Okay, try to let h as a subject matter. Okay, and then the questions asks us to minimize the amount of material. So this is referring to the area. Okay, so we must come up with the formula area for cylindrical. So we will have area 2 pi r square plus 2 pi r h. Okay, so we must substitute h here since we want to have one variable only. So 2 pi r squared plus 2 pi r times 1.5 over pi r squared. Okay, so we simplify. We will have 2 pi r squared. Okay, then plus 3 over r. Okay, then after that, we'll directly difference area with respect to r. We will have 4 pi r. Okay, and minus 3 over r squared. So we take this answer, we equate it with 0. Okay, we multiply everything with r squared. So 4 pi r cubed minus 3 equals to 0. Okay, then we will have r equals to cube root of 3 over 4 pi, which the value is 0.62. Okay, so now we want to test either r really minimize the amount of material, which now is area. So let's use the second derivative. Okay, so we find d2a dr2. Okay, so we will have 4 pi plus 6 over r cubed. Okay, so we substitute r equals to 0.62. Then our second derivative will be 4 pi plus 6 over 0.62 cubed is 37.74, which is greater than 0, and that means it's minimum. So we substitute, okay, r equals to 0.62 into h. Okay, so we will have h equals to 1.5 over pi times 0.62 square. So the answer is 1.24. So since the questions asks us determine the dimension, so answer here is dimension is r equals to 0.62 unit and h equals to 1.24 unit. Example 3, a rectangle is bounded by the x-axis and parabola y equals to 25 minus x squared as shown in the sketch. What length and width should be rectangle have so that its area is maximum? So mentioned here is rectangle have so that its area is maximum. That means our major things here is rectangle, which now is inscribed into parabola with given equations is y equals to 25 minus x squared. Okay, so we come up with the area for rectangle, which is A equals to, alright, so here is a point for this h, which is xy. So that means length from here to here is x. That means also here to here is x. That means length here is 2x, while this height is referring to the value y here. Okay, so area is 2x times y. where our y now is 25 minus x squared. So we expand, we will have 50x minus 2x cubed. Okay, so we different this area with respect to x. We will have 50 minus 6x squared. Then after that, we take that value, which is 50 minus 6x squared equate with 0. So we will have x squared equals to 25 over 3. Then x is plus minus 5 sub 3 over 3. Okay, next is negative 5 sub 3 over 3. Okay, then I want to try this value, okay, by using first derivative test. Okay, but now we are dealing with length. So we will exclude negative 5 sub 3 over 3 because logically length is cannot equals to negative. So I'll test 5 sub 3 over 3 only. Okay, so that means we have 5 sub 3 over 3. Okay, so we draw a simple table. So directly we choose our test value. Here is 0 while here is 10. Okay, then we substitute into our first derivative, which is dA per dx. We substitute, we will have positive. Here is negative. And the shape for positive is positive and negative like this. So that means here is maximum. Is that correct? Area is maximum? Yes. So by using the value, which is now is the questions want us to find the length and width, where the length is actually 2x. Where x we have 5 sub 3 over 3, so we substitute 5 sub 3 over 3 multiply with 2, so we will have 10 sub 3 over 3. So this is the length, okay, while the width is y, okay, where equals to 25 minus x squared. So 25 minus width 5 sub 3 over 3 square, we will have 50 over 3. So this is our length and this is our width. So please try this exercise and refer to the answer. For questions test yourself, a cylinder is placed inside an empty sphere with radius 10 cm as stated in the sketching. Find the largest volume of the cylinder. Okay, so based on the sketching, we consider this length, okay, which is 10 cm, since we have the radius of the sphere is 10. Okay, then the height is h. Okay, so that's mean cut into half, we will have h over 2. Okay, and r is the radius for the cylinder. Okay, so volume of the cylinder, v equals to pi r square h. Let r be the radius of a cylinder, h height of cylinder, and v is volume of cylinder. Okay, step 1, we have volume for cylinder is pi r square h. And from triangle, use the Pythagoras theorem. Okay, like this. Okay, then we will have h over 2 square plus r square equals to 10 square. So r square equals to 100 minus h square over 4, since we want to replace r square in the volume. Okay, so step 2, substitute, we will have v equals to pi times 100 minus h square over 4 multiply with the original h in the volume. Okay, so we simplify, we will have pi times 100h minus h cubed over. So step 3, we differentiate our v just now. We will have pi 100 minus 3 over 4 h square. Then we equate it with 0. So we will have h square equals to 400 over 3 and h is plus minus 20 over 3. Since h is a distance, length, so h must be positive. step 4, when h equals to 20 over sec 3, because we reject negative 20 over sec 3, okay, then we find the second derivative because we want to test this h. So we will get negative 3 over 2 pi h. Okay, when we substitute h, we will have negative 60 over 2 sec 3 pi, which is less than 0. That means the volume is maximum. Okay, then we conclude that h equals to 20 over sec 3. Okay, maximize the volume. Okay, step 5, we substitute this h into volume because the question asks us to find the largest volume. Then we simplify or press calculator. Okay, we will have 4,000 over 3 sec 3 pi centimeter cube. So guys, that means we end with 4.3. So we're gonna continue our next video with 4.4.